Slides are visible, right? Suraj?
Yes, ma'am.
Yes, ma'am.
Okay, I'll start. So in the last class, I started with the functional testing. In functional testing, I explained the different techniques for functional testing. One is the boundary value testing. Next one is the special value testing. And I also explained the worst case testing. Right, boundary value testing I explained. Then I explained the robustness testing, worst case testing, special value testing. Right. So today you are going to study the examples of a triangle problem, a next date function problem, and the commissional problem related to the different testing techniques. So first we'll start with the first example, that is the triangle example. Just a minute. This I explained. Okay. More it is not there. Okay. So first we'll consider the example of triangle problem for different testing strategies. So in the triangle problem, we have considered the four cases. What are those? What are those cases? What type of triangle it is that you have studied, right, in triangle problem. So we have considered four different cases. What are those? One is the isosceles triangle. Second one is the, which one? Isosceles. Next, Gaurav, three types of
Equal,
triangles.
equilateral and isosceles.
Isosceles. Next one.
Equilateral.
Isosceles. In one more.
Right angle.
Right angle.
Scalene, and fourth one is not a triangle option, right? Those things you are study. And if the triangle to be a equilateral triangle, then what should be the input? See, if the given triangle is said to be a equilateral, then what should be the input? Or
All
sides
the
of
sides
a
should be
triangle?
equal.
Yes, yes, tell me.
All the sides should be equal, ma'am.
If all the sides are equal, then the triangle is said to be a equilateral triangle. So that test case we can consider for testing, right? Next, if it is an isosceles triangle, then
Two
what
sides
should
must
be
be
the
equal.
condition for isosceles
Two,
triangle?
two sides must be equal.
Yes, two sides. If any of the two sides are equal, then we say that the given triangle is a isosceles triangle. Next one is scalene. When we say that it's a scalene triangle,
When all the sides are different, ma'am.
now, when all the sides are different, then we say that it is a scalene triangle. And if none of these three conditions satisfies, then we say that the triangle is a.
Ma'am, audio is not clear, ma'am.
It's not clear.
No, ma'am.
Clear. ಕೇಳಿಸ್ತಾ
No, ma'am.
ಇದೆಯಲ್ಲ ಕ್ಲಿಯರ್? ಹಲೋ,
Ma'am, disturbance ಇತ್ತು.
ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಇದೆಯಾ ಈಗ?
ಈಗ ಕ್ಲಿಯರ್ ಇದೆ ಮ್ಯಾಮ್ ಅವಾಗ.
Okay. So when none of these three cases satisfies, then we say that it is a what? So if the triangle is not a equilateral triangle, if the triangle is not a isosceles, or if the triangle is not a scalene, then what it is said to be?
Not a
One more
triangle.
option you have included, right?
Not a triangle. It's not
Yes,
a triangle.
not a triangle. So first we'll check for whether it is equilateral, isosceles, or scalene. If not, then we'll say that it is not a triangle. So these test cases we can consider. So if then we are considering three sides for a triangle, right? A, B, C. Then we check that if A equal to B equal to C, then we say that it's a equilateral. If A is equal to B and C is not equal, then we say that it is isosceles triangle, and scalene means A is not equal to B is not equal to C. And if all three conditions not satisfied, then we say that it is not a triangle. So for all these, we are developing the test cases by giving different values for A, B, C. So in the basic version, you said you studied that, right? Equilateral, isosceles, and then scalene, and not a triangle. But after that, in the improved version, we are fixing the value of A, B, C, right? What is the value of A, B, C that we have fixed in the triangle problem? A is equal to 200, B is equal to 200, and C is equal to 200. If the value is greater than that, then simply we say that it is not a triangle, right? Remembering? Yes? ಕೇಳಿಸ್ತಾ ಇದೆಯಲ್ಲ? So if we fix it, A is equal to A is between 1 to 200, B is between 1 to 200, C is between 1 to 200, then we say that the type of a triangle. If the value, if any one of the side value is greater than 200, simply we say that it is not a triangle, right? So for that we will consider different test cases and we'll say that whether it is a triangle or not, or the type of a triangle. So this is the one example. So here, if you consider what the boundary value analysis testing or robustness testing or the special value testing, etc. For all these, what we are going to do, we are going to develop the test cases where the test cases consisting of possible inputs and the expected output, right? So like that, we will write it in a table format. Here it is not there. Let us consider that. Let us consider that we are constructing a table of this form where it consisting of the case number, and there three sides of values you have to give, right? A, B, C. So we, in one column we will specify it as A, in another column we specify it as B, in another column we specify it as C, and what is the expected output. So if I give the A, B, C value as 50, 50, 50, then what is the expected output? Gaurav? If I give the case number, test case number 1, and A value is equal to 50, B is equal to 50, and C is equal to 50, what should be the expected output? What should be the expected output? Yes, Gaurav or Suraj?
Equilateral.
Yes, fine. Equilateral. So if we specify A is equal to 50, B is equal to 50, and C is equal to 50, then expected output is equilateral triangle. Right. Next, if I specify A is equal to 200, B is equal to 50, and C is equal to 50, then what it should be? What it should be? No, I'm fixing the A value as 200. Here we specified the condition that A should be between 1 and 200. If it is equal to or greater than 200, then we say that it is not a triangle. Okay, if any one of the sides A, B or C is equal to 200, then we say that it is not a triangle. Understood? Now I'll give third case, case 3. If A is equal to 80, B is equal to 200 and C is equal to 50, then what it should be? Expected output? Yes? See, I'm specifying the value A is equal to 80, B is equal to 200 and C is equal to 50. Then what should be the expected output?
Not a triangle.
Yes, not a triangle. So like that, we are constructing the number of test cases and testing on specifying the values for A, B, C. Depending on the value of A, B, C, we'll say that it is a equilateral, isosceles or scalene or not a triangle. Understood? Understood? This example we are considering for different types of testing, whether it may be a boundary value analysis testing or robustness testing or the special value testing. Okay, understood? Okay, next we'll consider one more example, that is the next date function. Okay, this is completed, right? See, for the next date function, we are considering the boundary value testing as well as the special value test cases. Okay, so first we'll see the boundary value test cases. So here, uh, uh, next date function that I already explained in the previous class, right? So here we are considering the number of months, number of days, and the number of years. And in the year, we are considering the range from 1812 to 2012, right? And if we give the month, day, and the year, next the function or the next date program will display the next day. Understood? Clear? So here, by using the boundary value analysis, we have constructed the test cases, and we are considering the number of test cases, and also we are specifying the month, day, and year. So case 1, case 2, like that we will have the number of test cases. So if it is a month 1 means it is a January, day 1 means January 1st. Okay, then year is 1812. Then what should be the next day or the expected output? The expected output should be the 2nd January 1812. So like this, we are constructing the number of test cases. So here, let us consider for 5 cases, we are considering for the first month and day 1, and what will be the next day for the different years: 1812, 13, 1912, 2011, and 2012. So for that, we are specifying the day and the month, and it is what will be the expected output that is listed in the last column. So like this. So next, we are constructing the number of test cases. Next, for the test case 6, we are considering the first month and the day is the second day. So January 2nd, and what will be the next day? Next day is January 3rd. So like that, for different years, we are considering. Similarly, by considering the different days, and like this, we can have the number of test cases, right? So here 15 test cases we are considering for the first month. Similarly, we can have the 15 more cases for the second month, third month, like that. Understood? So if we use the boundary value test cases, then it will have more number of test cases. So, but we don't want all this, because if you are testing the developed program or the implemented program for so many test cases, what happens? So it increases the time. Okay, you require more time for testing the program for each possible input. That's why instead of testing for all the values, we are considering the special value cases or special value test cases. Where it is? We are considering for special value test cases. What are special value test cases? Special value means it may be the end of the year or end of the month, and we are considering the leap year. So those values we are considering as the special value test cases, and only for such cases we are constructing the test cases and the developed program is tested. Now let us consider the special value case 1, and what is the month and the day and the year is also given. So here the month is the February month and day is the 28, and what is the year? 2012. Now 2012 is a leap year, right? And if it is the 28th February, then what will be the next day? The next day will be 29th February, because 2012 is the leap year. Understood? This we are considering as the special case, and that we are tested. Or by considering this test case, we are testing the implemented program. Similarly, we'll consider for one more year. Same month and same day, we are considering day 28, month 2, and it is 2013. So here, what will be the next day? The next day will be March 1st. Why? Because 2013 is not a leap year. So if it is a leap year, then only we'll get the 29th in the February. Otherwise, it will be displayed. The next day will be displayed as March 1st. Understood? Next, one more special case we are considering. Once again, we are considering the month 2 and the day is 29 and the year is 2012. So now since 2012 is a leap year and if we are specifying 29 as the day, then what will be the next day? The next day will be March 1st because the 2012 consisting of February 29. So 29 days in the February. That's why when we are in running the program by giving this input, it will display the next day as March 1st 2012. Understood? Like this. In the special value test cases, we are not constructing the test cases for all possible inputs, but we are only considering the special cases like the leap year and the end of the year or the end of the month, etc. And we'll test the implemented program only for these special value test cases. Understood? Any doubt in this? Any doubt? Yes, Suraj, understood?
Yes,
Gaurav?
ma'am.
Gaurav? Then what is the difference boundary value testing and special value testing? In the boundary value testing, we are considering all possible test cases, right? So it may end up with n number of test cases, right? But in the special value test cases, we are considering only the special values or only the special test cases, and the implemented program is tested only for the special test cases. Understood? Next, one more is there, right? That is the commission problem. So for the commission problem, there we have consider the three different percentage of commission. If the salesperson sells the product up to $1,000, then it is up to 10%, and if it is between $1,000 and $1,800, then the salesperson is going to get a 15% of the commission. And if the salesperson sells the barrels or the rifles or stocks for more than $1,800, then he is going to get the commission of 20%. And if it is more than 1,800, is getting 20%, right? So these are defined here. The inner one, this is see here we have three triangles, right? This is one, second, and this is the third one. Or if we consider this is the first cube, second cube, and the third cube, the values, the values which are within the first cube belongs to the 10% of the commission. Means if the salesperson sells the barrel stocks or the logs up to $1,000, then he is getting the 10% of the commission. Means what it indicates: 40, 33.3, 22.2. These are nothing but the number of stocks, logs, and barrels which are sold by the salesperson. See here. So since we have three types of material, one is the logs, second one is the stocks, and third one is the barrels, that we are representing in the form of XYZ axis. Along x-axis we have logs, along y-axis we have barrels, and along third z-axis the stocks are represented. Then we have constructed the cube by joining the values of the x-axis, y-axis, and z-axis. So then we'll get three types of cubes. One is for the 10% of this commission, second one is for the 15%, and third one is for the 20% of the commission. So if the salesperson sells up to 40 barrels, 22.2 logs, or 33.3 stocks, then he is able to get only 10% of the commission. Understood? Next, if the salesperson sells up to 40 logs, 60 stocks, and 72 barrels, then he is going to get up to 15% of the commission. And if the salesperson sells above 40 logs, above 60 stocks and above 72 barrels are more than 40, 60 and 72 barrels, then the salesperson is eligible for 20% of the commission. Understood? That we are representing in the form of a cube, where we are considering the log, stocks and barrels along X, Y and Z axis. Now, when the salesperson gets the maximum of 20% commission, if he sells a minimum of sorry, if he sells up to 70 logs, 80 stocks and 90 barrels, then the salesperson is eligible for getting the 20% of the commission. So here we will have the different test cases. The test cases for cube 1, test cases for cube 2, and third one is the test cases for cube 3. Cube 3 belongs to 20% of the commission, cube 2 belongs to 15% of the commission, and cube 1 for 10% commission. And whatever the values you consider within this cube, or whatever the values less than 22.2, less than 33.3 and less than 40, and all these test cases belongs to the 10% of the commission. So for this cube we can have n number of test cases. Similarly for this one, second cube, we will have n number of test cases, and similarly for cube 3 we will have n number of test cases. Right, if we use the special boundary value testing, then for each cube we can have n number of test cases. But if we use the special value test cases, then we'll consider the values which are at the end, or which are at the end point of cube 1, cube 2 and cube 3. Then we will have the limited number of test cases when compared to the boundary value analysis testing, because in the special value testing we are only considering the special cases, and by using those special test cases we are testing the implemented program. Understood? For the next date function I explained, right? Next one is the boundary value test cases for next date. So this I explained, right? So if you consider the boundary value test cases for the next date function, what are the observations we can have? Not much reason for robustness testing, good reasons for worst case testing. So because in the see here in the next dates we can have the different test cases like this. So next date for December 31st 1991, what the expected output of this, it returns January 1st 1992. Similarly for the February 21st or February 28th, if it is not the leap year, then it is returns the value as March 1st. If it is a leap year, then it returns the value as February 29. So this I explained in the last class itself, right? These are the reasons. And larger number of test cases, 15 normal boundary value test cases and 125 worst case boundary value test cases. Sorry. Because so worst case testing means we are considering all the test cases in order to test the developed program or the implemented program. So hence it leads to more number of test cases when compared to the boundary value test cases. So this I explained, right? Special value test cases I explained. Next one is output range test cases. So here when we are defining the test cases for the next date function, so here we can easily identify the range and domain. Here the range and domain are identical for one day, and see here, since whenever we are displaying the next date, so first simply we'll check whether it is a leap year or not. If not leap year, then we'll see the number of days in the February, right? And for the remaining months, it is very easy. So if it is within the given range, then it is easily displaying the next date. If not, then it will display the wrong input range or wrong output range. So for example, here we are considering the years from 1812 to 2012. If I give the input as January 1st, 1800 or 1800, then what it will display? It will display the error as not in the input is not in the range. Why? Because we are considering the years from 1812 to 2012. So I have to give the input within that range. If not, it will display the error as the output, the input is not within the given range. Right. Uh, so it is easily, we can check those conditions, right? Then what are the advantages and disadvantages of boundary value testing? The advantages are the commercial tool is already available to support the boundary value testing, and the boundary value testing is easy to automate, and this is useful for the calculation intensive applications with variables that represents the physical quantities such as the meters, degrees or kilograms. When it is there, we can easily use the boundary value testing, and we can easily calculate the values by for the examples which includes the units such as the meters, degrees or kilograms. But the disadvantage of this is inevitable potential for both gaps and redundancies. So that I explained in the first day itself. So what is the problem with the boundary value testing? So it is displaying the gaps and the redundancies. That is the major disadvantage of boundary value testing. And and these gaps and redundancies are never identified by the boundary value testing, and this cannot be used for larger number of testing cases or larger number of applications. And these whenever we are using the tools for boundary value testings, they generate only the inputs, but they are not generating the outputs. But what we want, the user or the end users or the customers needs that the tools must generate the expected outputs also. So these are the advantages and disadvantages of boundary value testing. So this completes the uh, boundary value testing and robustness testing, special value testing, and worst case testing. So fifth chapter is completed. In the next class, I am going to start the sixth chapter. In the sixth chapter, you are going to study about equivalence class testing. Any doubt?
No, ma'am.
Okay. Yes. Just a minute. Okay, if you don't have any doubts, ರಘು ಈಗ ಜಾಯಿನ್ ಆಗ್ತಿದ್ದೀರಲ್ಲಪ್ಪ.